I can't. Anyway, it is pretty neat. It's a satellite system. We have a couple of them, actually, and is one of our, in fact, I think it's the only DoD experiment we have aboard, but it uses CO2 gas to maneuver itself, and we can actually get these two satellites to fly in formation with each other and actually dock to each other. So that's a pretty fun experiment. We got to do that a little bit last weekend.
And I think I see the idea there that you couldn't do that.
Anyway, that's kind of a very rough overview.
Couldn't do it on Earth where there's gravity. You need to be in space. Are we able to move over to the window? Are you? Can Thomas move the camera over there and show us the view out?
Sure, you bet. He's showing you our laptop right now, which shows you where we are. Obviously, we are just crossed over the west coast of Africa after having passed through the North Atlantic. And he will now take the camera down into the lab window and show you exactly what it looks like from here. The terrain below, how would I say it? It is an experience that makes you really appreciate what we have down there, that it's fragile, that we need to protect it, and you feel very detached from it, and sort of you miss it. It's your home, it's where all your loved ones are, where all of your experiences have happened, and you really get a sense of being separated from it in a way.
Now, I think in terms of the imagery and experiments, people sometimes wonder, I mean, we have unmanned satellites that circle the Earth and take this kind of photography, but there's some advantage too to what you can do, right? With a human looking out there to where to focus in, where to take the shots? Looking out there to where to focus in, where to take the shots?
Well, certainly the advantage that humans have over robots is that we can adapt quickly. We can, respond to changing situations. For instance, my predecessor as science officer aboard on Expedition 13, Jeff Williams, managed to take a picture of a volcano that was erupting in the Aleutian Island chain, and even if they wanted to program a satellite to take a picture of it, nobody could know when it was going to happen or when the satellite would be there. It would take a while to get there. It was a very short eruption, and he managed to take a shot of it. So, yes, we do have the ability to respond in more real time. And I think we also have a different sense of, art in a way. We can take pictures that a satellite might not want to take because from a science standpoint, it might not be all that interesting, but we are all humans after all, and the pictures actually appeal to a different sense than just the science.
Mike, let's go to the food now. I think this is the fun stuff for viewers, I think. Can you show us how you manage up there? I mean, I can only imagine that it's very, very difficult in space where juices and things like that want to float all over the cabin, crumbs. But how do you deal? Just give us a little lesson in it. How do you deal? Just give us a little lesson in it.
Well, you're right. I mean, it's different. It's some of it's challenging, some of it's fun. I've prepared a couple of items for your consideration. First of all, our food comes in a variety of different forms. Some of it is dehydrated, and some of it is thermal stabilized. Some of it comes in its natural form. This is soup before it's dehydrated. It doesn't look particularly appetizing. And this is soup. It's noodle soup with meat after it's been hydrated. It looks a little bit better. You can choose to eat this soup with a spoon if you'd like, but it's more practical just to use this sort of built-in straw device.
That all looks so difficult, and I know studies have shown that eating is very psychologically important for crews on space stations where they're away from the Earth for a long time. Are you able to get some pleasure out of eating, even though it's a lot more difficult than on Earth?
Absolutely. Well, first of all, you're right. Eating is extremely important, and it's the folks at NASA and the Russian Space Agency go to great lengths to try to, accommodate our tastes and our what we think we're going to like on orbit. Of course, people's tastes tend to change. We tend to like things that are a bit more spicy. You can imagine that salt and pepper don't work so well up here, so we actually have our salt, pepper, soy sauce, and actually some wasabi in a different sort of a form. This is actually salt, and in order to apply it, you just remove the lid and squirt some. You can see some of it is caked on the outside, but you just sort of squirt some onto whatever
Yeah,
your
I got
food
the
is.
idea there. If you were shaking it like a
of course,
salt and
and then
pepper
you
shaker,
mentioned
it'd go all
fun
over the laboratory, right? The crumbs, the salt and the pepper.
Yeah, yes, the salt granules would definitely be problematic. Of course, these candy-coated almonds are a real treat. They taste about the same, but they're obviously a lot more fun. If you'd like, you could perhaps try one.
In high definition, that's something coming at us like that.
In high definition, that's something coming at us like that.
And then drinking, of course, this is what tea might look like, or what it does look like, before it's been hydrated. This is tea with sugar, so you can see the tea bag inside, along with the sugar. And then once you hydrate it, we put about 200 milliliters or so of water in there, and it actually tastes quite good. Same idea in this. This is orange pineapple drink, and of course you got to be careful. I would be remiss if I didn't do the obligatory orange bubble trick.
Nice.
Nice.
Fluids in space end up taking the form of spheres to reduce the or due to surface tension, and you can sort of play with it as much as you want. You can blow on it to get it to do certain things, but the best thing to do with it is to eat it or drink it.
So simple. That looks great.
We have some.
So simple, that looks great.
We have some fajitas on board that we could use. These are actually, obviously, in its natural form, tortillas. So we would just take the tortillas and then take the fajitas, which I'll show you a shot of inside. Pretty appetizing. We have chicken fajitas, beef fajitas. There are probably over 200 different menu selection items, and we build our own menus. We eat each other's food. This one has a red dot on it. That means it's mine, but it doesn't matter. We eat each other's food, and we build a menu that supposedly goes by days.
So you're
but
living pretty
basically,
well
when
up
it's time
there.
to eat, you just look in the pantry, take out what looks good, and eat it. We do okay up here.
Mike, I think we're out of time, but I want to thank you a whole lot for taking time out of your incredibly busy work schedule to share a very special technology first with our viewers, seeing you live in HD TV. I mean, seeing the pictures from here on Earth, it's really like being there. So thanks a lot, Mike.
Seeing the pictures from here on Earth, it's really like being there. So thanks a lot, Mike.
Robert, it is our pleasure, the Expedition 14 crew of the International Space Station Alpha, as well as the NASA team, to participate in this first ever HDTV event. We had a great time showing you kind of what it is that we do up here day to day, and we look forward to more of the same in the future.
Great, Mike. That was just a lot of fun.
Thank you and good day.
Good day to you. You know, I've been covering the space program for many years, and I've seen the evolution of these live images coming back from space since the days of the Apollo missions. And I gotta say, this is truly amazing. So thanks everyone for watching. This has been a live broadcast special of Discovery HD Theater on Momentous Technology First, the first live broadcast from the International Space Station in high definition. This is Robert Hager. So long from Discovery.